Friends, today we are going to discuss an important chapter, alternating current. Highly mathematical, highly problematic, and a theory-oriented section also. Therefore, today we are going to discuss the questions of alternating current. We'll go through one by one. The first question is about the average value of AC. The instantaneous voltage in an AC supply is given by V equals V0 sine omega t. And plotting the graph, we will get the shape of the graph like this. Omega t and voltage. That is, it will have different values at different instants, or the graph is a sine wave. Therefore, considering one complete cycle, the average value becomes 0. Positive half cycle and negative half cycle are there. Average value becomes 0. Therefore, in the definition of average value of AC, considering one complete cycle, the average value becomes 0. That is, positive half cycle and negative half cycle are there. Therefore, in the case of the average value of an AC cycle, we made special definition. That is, average value of an AC is the mean value over half a cycle, not over the entire cycle. That is, the mean value over half a cycle of an alternating signal is called average value of AC. And it is given as integral 0 to t by 2 over half a cycle. Therefore, the limit is 0 to t by 2. T is the time period. I dt, summation of the instantaneous currents over half cycle divided by 0 to t by 2 dt. After finding the summation of different instantaneous values, then divide by the total time interval for half cycle. Integral 0 to t by 2 I dt divided by integral 0 to t by 2 dt. Solving, we will get the result. I equal to I0 sine omega t. Finally, we get the result as 2 I0 by pi. And in the case of voltage, 2 V0 by pi. That is, average value of an alternating current is 2 I0 by pi, or alternating voltage is 2 V0 by pi. Now, let's go through the choices. The average value of AC is given by I0 by pi. It is wrong. Second case, integral 0 to t by 2 I dt. No, it is the summation only. Third choice, integral 0 to t by 2 I dt divided by 0 to t by 2 dt. That becomes t by 2. Therefore, the correct choice is C. C choice is the correct answer for the first question. Question number 2 is about the RMS value, root mean square value. RMS value of an AC is also known as effective value or virtual value. And what is the definition of RMS value? It is the magnitude of the equivalent DC which creates the same heating effect in a conductor as that of the given AC, and is given by IRMS equal to I0 by root 2, or similarly VRMS is equal to V0 by root 2. Let us check the way how it was obtained. Okay. Root mean square, that is the expansion of RMS. Then first summation of the squares of the current. Integral 0 to t I square dt divided by integral 0 to t over full cycle. The summation of the squares are done. Then integral 0 to t dt divided by the total time. Now we have obtained the average value of the square, mean value of the square, then raised to half, root mean square value. This is the method to find the value of RMS value, IRMS. equal to root mean square value. First summation of the square values over one cycle, then divided by total time interval during one complete cycle. Then we get the average value of the squares. Then take the root raised to half. Root mean square. Substituting the value of I as I0 sin omega t, we get the result IRMS equal to I0 by root 2. Similarly, VRMS equal to V0 by root 2. Now the question is, the RMS value of AC is given by, let's check, integral 0 to t by 2, integral 0 to t I square dt divided by total time interval, raised to half. First choice is the correct answer. Summation of squares over one complete cycle, integral 0 to t I square dt divided by total time over one complete cycle, that is time period, raised to half means root. This is given in the first choice. Therefore, the correct answer is A. Question number 3. The ratio V0 divided by V0 by root 2. V0 means maximum value in a cycle of AC. V equal to V0 sin omega t, where V0 is the amplitude of the signal, maximum possible value in one complete cycle. That's V0. V0 by root 2 means the RMS value of the voltage of an AC signal. Here the question is V0 divided by V0 by root 2. V0 peak value divided by V0 by root 2, RMS value. Peak value to the effective value, that ratio is called peak factor of AC. Similarly, the ratio of the effective value to the average value is called form factor of AC. Peak factor, the value of peak factor is V0 divided by V0 by root 2, that is root 2 or 1.414. This is the value of peak factor. Here the question is the ratio V0 by root 2 equal to dash, means that ratio is called, rather the ratio of peak value to the effective value or peak value to the RMS value is called peak factor of AC. Therefore, here the correct choice is peak factor of AC. B choice is the correct answer. Question number 4. The ratio IRMS divided by I average. IRMS divided by I average. RMS value means I0 by root 2. Average value is 2I0 by pi. Effective value to the average value, this is called a form factor of AC, and it becomes pi by 2 root 2 or 1.11. This is the value of form factor of AC. Form factor is the ratio of the effective value to the average value. It becomes so, and the final value is 1.11. Now, peak factor already mentioned, peak value to the effective value. Now the answer is form factor of AC. Therefore, the correct choice is B. Here two more choices are there. Power factor, that is a correction factor given to the apparent value of power to get the average value of power. Actually, if the measured values are taken, that is, in an AC supply, the measured values always will be equal to RMS value. If the voltage is measured, it is the RMS voltage. Current is measured, it will be equal to the RMS value of current. If the voltage and current are given after the measurement, that is V effective, I effective, if the product is taken, it is called the apparent power of the supply. V effective, I effective does not give the actual power. To get the actual power, this apparent power is to be multiplied by a correction factor cos phi. That correction factor by which the apparent power is to be multiplied to get the average power or actual power is called power factor of AC. That is given in the third choice. Fourth one, Q factor. In an LCR resonance circuit, the ratio of any of the reactance to the resistance is called quality factor or Q factor of AC. These are all existing terms, but here the correct answer is B. Form factor is the correct choice. That is, B choice is the correct answer. Question number 5. It is slightly mathematical also. The instantaneous current of a circuit is given as I equals minus of J V0 by Z e raised to J omega T. This is the given data. E raised to J omega T. Here V0 is the amplitude, maximum voltage. Z is the impedance of the circuit. The instantaneous voltage in an AC supply in terms of J operator can be represented as V equal to V0 e raised to J omega T. Here there is a minus J also at the beginning. Minus J means minus J equal to e raised to minus of J pi by 2. Substituting the value of minus J here the equation of the instantaneous current becomes V0 by Z e raised to J omega T minus pi by 2. That is, current lags behind the voltage by a phase angle pi by 2. And this is happening for an AC circuit having inductor only, L only. For an AC circuit having inductor only, the instantaneous current is given by I equal to V0 by Z sin omega T minus pi by 2. In the complex representation form, it appears as V0 by Z e raised to J omega T minus pi by 2. That is the circuit. If the circuit is having L only, the instantaneous current equation becomes I equal to V0 by Z e raised to J omega T minus pi by 2. Here the question is, the instantaneous current is given as I equal to minus J V0 by Z e raised to J omega T. The circuit contains, here we understood already, current lags behind the voltage by a phase angle pi by 2. This is happening for a circuit having inductor only. Therefore, the correct choice is C. Circuit having L only. C is the correct choice. In the next question, a graph is given. In the given graph, instantaneous voltage is plotted and instantaneous current is also plotted. And from the graph, we can identify one thing, that the current lags behind the voltage by a phase angle which is not equal to pi by 2. Anyway, current lags behind the voltage by a phase angle. If the phase difference is pi by 2, it will be the circuit having L only. Here, phase difference is not equal to pi by 2. Current lags behind the voltage, and these conditions are happening for a circuit having inductor and resistor only. That is LR series AC circuit only. Such a graph is existing for an AC circuit having L and R only. Therefore, the correct choice is L and R means the phase difference is phi, and if an inductor is present in an AC circuit, the current will have a tendency to lag behind the voltage. If a capacitor is present in an AC circuit, the current will have a tendency to lead ahead of the voltage. Here, from the graph, we understood that the circuit is having L and R only. That is, L is there, inductor is there. Therefore, current lags behind the voltage. Therefore, here, lagging factor, current lags means in the power, it should be minus. V0 by Z e raised to J omega T minus phi. The phase difference is not equal to pi by 2. If the phase difference is pi by 2, correct choice will be C. But here, the phase difference is not equal to pi by 2. It is only phi. Then the correct choice is A. V0 by Z e raised to J omega T minus phi. That is the equation for an LR series AC circuit. C choice is the correct answer. Question number 7. In the above case, the impedance of the circuit, above case means LR series AC circuit. In an LR series AC circuit, the reactances L omega, inductive reactance XL equal to L omega. Resistance is also there. Then the impedance of the circuit from the impedance triangle, the impedance of the circuit will be obtained as Z equal to root of R square plus L omega or XL L omega whole square. This is the impedance equation. In the complex form, this can be represented as Z is equal to R plus JX, where X is the reactive part, R is the resistance, real part and imaginary part. In the complex form, impedance can be represented as Z equal to R plus JX, and generally we can write Z is equal to root of R square plus L omega the whole square, or Z equal to root of R square plus XL square. Now, in the given question, in the above case, that is LR series AC circuit, the impedance of the circuit is A choice is wrong, B choice is wrong, C, XC, that is capacitive reactance, it's also wrong. The correct answer is R plus JX or root of R square plus XL square. Here the given answer, given in the given case, D choice is the correct answer, that is impedance equal to R plus JX. Again, question number 8 is also associated with a graph. From the graph, we can identify that the voltage and current are in phase. Such a situation is occurring for the case of R only and in an LCR resonant series circuit. Also, the same thing comes. Therefore, in accordance with the graph, the circuit can be either R only or LCR resonant circuit. Therefore, let's go through the choices. L only wrong, R only correct, LCR resonant circuit is also correct. Then B and C, D choice is the correct answer. Question number 9. A problem from AC, and it's a typical problem from alternating circuit. എല്ലാ പരീക്ഷകൾക്കും ചോദിക്കാൻ ചാൻസ് ഉള്ള ഒരു ടിപ്പിക്കൽ എക്സാമ്പിൾ. ഐ റീഡ് ദി ക്വസ്റ്റ്യൻ ഫസ്റ്റ്. എ 10 watt 20 volt lamp is connected across a 20 hertz 100 volt supply. Lamp means a resistor. 10 watt 20 volt lamp is connected across a 100 volt 20 hertz supply. 20 hertz means it's an AC signal, 100 volt supply. Then inductance of the choke coil to be connected in series so as to run the lamp. What is the value of L to run the lamp? This is the question. From the given data of bulb, we can identify VI equal to power. If we take this equation to identify the current, I will be obtained as half ampere. Then I squared R equal to power can be used for the bulb rating. Then the resistance of the filament of the bulb will be obtained as 40 ohm. 1 by 2 square R equal to 10, 40 ohm. Now, circuit voltage divided by circuit current, that is 100 volt divided by circuit current half ampere equal to impedance of the circuit, that is 200 ohm. Circuit current is obtained, the resistance of the filament lamp is obtained, then impedance of the circuit is also obtained. Then the impedance equation is Z square equal to R square plus L omega the whole square. That is impedance square 10 raised to 4 into 4, 200 square minus R square 40 square 0.16, 40 square 0.16 into 10 raised to 4 equal to L squared omega square. Omega is 2 pi f. Frequency is 20 hertz, then 40 pi omega square. This is the substitution. 40 pi square means 10 raised to 4 into 4 minus 0.16 equal to L square. 40 pi square means 1600 into 10. Pi square almost at 10. Then 1.6 into 10 raised to 4. 1.6 into 10 raised to 4. Now 10 raised to 4 cancels. Then 3.84 divided by 1.6 inside the root will give inductor. That is 2.4 almost will give inside the root. Square root or exact value calculate it comes around 2 point something. Then its root is 1.5 Henry. From the choice we can identify easily. Therefore, the correct answer is the inductance of the choke coil to be connected in series so as to run the lamp is L equal to 1.5 Henry. Henry is the unit of inductance. Therefore, the correct choice is B. A figure is given for the next question. And the question is, the voltage across the inductor. It's an LCR series circuit. LCR series circuit. Supply voltage is there. Now 100 volt. It is given, supply is 100 volt. Now the other two voltages are also given, 40 volt and 80 volt. Voltage across resistor 80 volt, voltage across capacitor 40 volt. From the impedance triangle, we have an expression, supply voltage square equal to the voltage across the resistor square plus VL minus VC, voltage across the inductor minus voltage across capacitor whole square. From this expression, everything is given. Supply voltage 100, voltage across the resistor 80, then voltage across the inductor unknown, this is 40. Therefore, the value of VL, voltage across the inductor, should be 100 volt. Then the equation will be satisfied there. Therefore, the voltage across the inductor is 100 volt. That is, the correct choice is C. Question number 11. It's a very good problem. A typical problem from the alternating current circuit. I'll read the question first. A 10 watt 20 volt lamp is connected across 10 watt 20 volt lamp is connected across a 50 hertz 100 volt supply. Then the capacitance of a capacitor to be connected in series so as to run the lamp. That is, what should be the value of the capacitance? That's the question. From the given rating of the bulb, we can identify the value of current as I equal to VI equal to power, then I equal to half ampere. Then from the equation I squared R, we get the value of resistance as 40 ohm. 1 by 2 square R equal to 10, therefore 40 ohm. Then impedance of the circuit is circuit voltage divided by circuit current. 100 volt divided by half ampere equal to 200 ohm. Now the impedance equation, Z square equal to R square plus 1 by C omega the whole square. Capacitive reactance is 1 by C omega. Now I am going to substitute Z square 10 raised to 4 into 4 minus R square 1600 0.16 into 10 raised to 4 equal to 1 by C square omega 2 pi f. 50 hertz means omega is in radian per second, 100 pi. Then 100 square 10 raised to 4, pi square again nearly a 10, then 10 raised to 5. 1 by C square omega square. Therefore, C can be written as whole inside the root 1 by 10 raised to 4 into 10 raised to 5, 10 raised to 9, then 10 raised to 8 into 10. I'll write like this. 10 raised to 9 is already written. Then 3.84. 10 raised to 8 when it comes outside, 10 raised to 4, and at the numerator it becomes 10 raised to minus 4 into inside the root 1 by almost 40, that is 0.16, or it can be approximated as 0.16. Then the correct answer is 16 into 10 raised to minus 6, that is 16 microfarad is the capacitance of the capacitor. Therefore, the correct choice is A. 16 microfarad is the correct answer. That is A choice is the answer. Next question is about a unit. The SI unit of reactance in an AC circuit. First, I will discuss about DC. In a DC circuit, when a current I is flowing through a resistor, we get a voltage drop across it. And this ability to create a voltage drop, we call it as resistive effect. But in an AC supply, the same property is offered by that ability to create a voltage drop is created by an inductor, a capacitor, and across a resistor. That means the resistive effect is offered by these three components in an AC supply. And the resistive effect offered by the inductor is called inductive reactance, L omega. Resistive effect offered by the capacitor is called capacitive reactance, given by 1 by C omega. Whatever it is, the unit of resistance, reactance, and also for the impedance, the unit will be ohm. All are resistive effect. The unit of impedance and that of resistance. For unit of resistance, reactance, and impedance, all will be ohm. Therefore, here the correct answer is B. The SI unit of reactance is ohm. That is B choice is the correct answer. Question number 13. Which of the following are having the same unit? Admittance and resistance. Okay. In an AC circuit, the resistive effect is offered by a resistor, inductor, and across a capacitor. Offered by a resistor, inductor, and a capacitor. The resistive effect offered by the inductor is called inductive reactance, and that offered by a capacitor is called capacitive reactance, and the net resistive effect of the entire circuit is called impedance of the circuit. Here, impedance, inductive reactance, capacitive reactance, and the resistance all will have the unit ohm. 1 by resistance is called conductance. Similarly, 1 by impedance is called admittance. First, you know all these terms. Now, let's go through the choices. First choice is admittance and resistance. Admittance is 1 by impedance. Ohm raised to minus 1 will be its unit. Then it is wrong. Then B choice, reactance and impedance. Reactance has the unit ohm. Impedance also will have the unit ohm. Therefore, it is the correct choice. Then admittance and capacitive reactance. Admittance 1 by ohm. Capacitive reactance ohm. It's also wrong. Then D choice, conductance and impedance. Conductance 1 by ohm. Impedance ohm. Therefore, here the correct choice is reactance and impedance both will have the unit ohm. Therefore, the correct choice is B. Question number 14. The instantaneous voltage of an AC supply is V equals 10 sin omega t. And the instantaneous current is I equals 2 cos omega t. V equal to V0 sin omega t, I equal to I0 sin omega t. These are all the instantaneous values of alternating signals. V0 is 10. Therefore, the RMS value is V0 by root 2. V0 by root 2 will give the RMS voltage. Similarly, I0 by root 2 will give the RMS value of current. Here, RMS value of voltage is 10 by root 2. Similarly, RMS value of current is 2 by root 2. The product of the two effective values of voltage and current This product always gives the apparent power of the supply. This does not give the actual power. This is called apparent power. And to get the actual power, this apparent power is to be multiplied by a correction factor cos phi. And that correction factor by which the apparent power is to be multiplied to get the average power is called power factor of the AC. Here, the instantaneous voltage and the instantaneous current are given. But the second one is cos function. First one is sine function. Therefore, the phase difference between the voltage and current is pi by 2. Now, to get the actual power, the apparent power is to be multiplied by a correction factor cos phi. Here the value of phi is pi by 2. Therefore, cos pi by 2 is 0. Therefore, the actual power or average power is 0. Now the question is, the power of the supply is, in the given case, the average power is 0 since the phase difference between the voltage and current is pi by 2. Hence the answer is 0. That is, here the correct choice is D. Question number 15. Here also a graph is given. But from this graph, we can identify a lot of things. First of all, current lags behind the voltage by a phase angle. The phase difference between the voltage and current, here it is pi by 2 because the peak of one coinciding with the 0 of the other. Therefore, phase difference is pi by 2 and the current is lagging behind the voltage. Current lags behind the voltage by a phase difference of pi by 2. This condition is occurring only for a circuit having inductor only. That is, here we can identify that the circuit is L only circuit. Therefore, here the correct choice is C. That is, for a circuit having an inductor only, the current always lags behind the voltage by a phase angle pi by 2. The correct choice is C. Now, we have discussed 15 questions from alternating current. It's a very important topic and highly problematic topic. All the important problems we have covered through this question paper. Please go through the theory part and all the questions, all the problematic questions in detail, and wish you all the best. Thank you.